Welcome to another video on our Amazon Cloud series. In previous videos, we've covered deploying a monolithic application. We did everything manually. Then we covered infrastructure as code, took a look at some DevOps and CI/CD best practices. Then we started jumping into how to scale our application. So first we considered database scaling options, and we looked at a few ranging from self-managed options to fully managed to how to set up a MySQL master-slave configuration. Then we moved on to scaling our queue, and we used Redis for that. And we considered deploying Redis to an EC2 instance and vertically scaling that. We also considered using Elasticache. In this video, we're going to look at scaling our workers. We have a job queue, and we have workers that are pulling jobs off that queue, and they're continually processing data. We're deploying a Laravel application, so we're using Laravel Horizon for this, and that works just great. The challenge we have right now is that Horizon is deployed to the same EC2 instance as our web servers. So we're gonna have to tweeze those two things apart. And that's what we're gonna do in this video. In a future video, we're gonna start looking at scaling that web application. When we get to those videos, we'll look at considerations such as optimal Nginx and PHP FPM configurations. We'll also consider vertical scaling, and then all of our options for horizontal scaling, including putting multiple instances behind an application load balancer. So if you're enjoying content like this, go ahead and hit that like button and subscribe. So this is a recap of the roadmap and where we've been. This is where we are today. So this is where we're going to start taking a look at how we can scale Laravel Horizon. Just in case you're jumping in here without the knowledge of the previous videos, we are deploying a Laravel application. It's in a GitHub repo. It's pretty much bare bones Laravel 11. There are a few modifications, but not many. This is our tech stack. And these are the tiers that we're dealing with. We've got a web tier, database tier, and we have some workers that are pulling jobs off a queue. We have a scheduler that are putting jobs on the queue. And in addition, the web application itself can put jobs on that queue. We started off with a monolithic application where we deployed all of those tiers to one EC2 instance. And that works great for small applications or maybe your dev environment. But at some point, if the application becomes larger, we have to start introducing multiple tiers. So we introduced a 2-tier deployment where we pulled off the database tier and we deployed it to Amazon RDS, which is a fully managed service, so we could really scale that pretty easily. We deployed that across multiple availability zones, so we had some redundancy built in. Then we looked at a 3-tier deployment where we pulled off the caching tiers. So at this point, all of our data is in fully managed applications that are deployed to Amazon. We used Amazon RDS, which was a MySQL compatible database option, and then we used Amazon Elasticache, which was a Redis compatible caching option. Today, we're going to move to a 4-tier application. So we're finally going to have our web tier all by itself, and that's going to lend us to future videos where we're going to scale out the web by having multiple instances of the web tier, maybe behind an application load balancer. But today, we're going to deploy these workers and the scheduler to their own EC2 instance. And if we take a look at the Amazon infrastructure that we're deploying, we have a single VPC that has 2 availability zones. And in each availability zone, there's a public and a private subnet. We've deployed our web tier to a public subnet. What we wanted to be able to do is deploy this worker tier to a private subnet. We also have these caching tier, which is Elasticache and Amazon RDS, which is our database tier. So these are deployed across all availability zones on our VPC. So this is the new tier that we're going to work on today. So at this point, there's nothing left but to get to it. Okay, so let's discuss strategy before we start deploying this thing. So first we're going to have to create a NAT gateway, and that's going to allow our EC2 instance that we create in our private subnet to have access to the internet. And we are going to need this because we're going to want to do things like apt install. So that's a very important thing. So we're going to do this first, and then we're going to create the EC2 instance second. After we create this EC2 instance, we're going to provision it pretty much the same way we provision the web tier. And the only difference is we're not going to have to install some of the services like Nginx. Then after we get our application installed on this worker tier, we're going to have Laravel Horizon run here in Supervisor. And we're also going to have a cron run in here that's going to run PHP artisan schedule. So I can shut those 2 things down on the web tier. After that, I think we should be good to go. So let's go ahead and get at it. Okay, so here we are at our AWS console. First thing we're going to do is we're going to create that NAT gateway. Let's go to the VPC that we have. And down here on the left-hand side, you see the NAT gateway. We're going to create one of those. And so you can see an old NAT gateway that I've already deleted. So we're going to recreate that. And we'll click Create NAT Gateway. We're going to name this Laravel Demo NAT. For the subnet, we're going to deploy this in the Laravel demo public subnet number 1, which is right here. And one of the reasons I don't keep these NAT gateways around is because they require an elastic IP address, which is an additional cost. So I generally, if I'm not using them, I just kind of remove them. And that's why I don't just have a NAT gateway hanging around all the time. So I allocate this elastic IP address, and everything else is the same. So we're going to go ahead and create this NAT gateway. While that NAT gateway is being provisioned, let's go back to our VPC and look at our resource map. And down here in our resource map, what we're going to see is we have our NAT gateway, which is over here, but it's not connected up to our private subnets. So our private subnets have this route table, but it's not connected to the NAT gateway. If you look at the public subnets, they have a route table that's connected to the internet gateway. So we have to just add a route from our route table for the private subnets to our NATs. So let's do that next. We're going to click here. Down here at the routes, we're going to edit our routes. We're going to add a catch-all for all that outbound traffic and select that NAT gateway that we just created. And I'm not quite sure which one it is, since there's one that's being deleted and one that's being spun up. Let me go back and look at our list here. So the one that's being deleted is the one that doesn't have the A after the R. So that's what we're going to do, is we're going to go with the one that's not being deleted, spelled correctly, and we'll save our changes. So our NAT gateway now, our new one, is now available. And if we look at our VPC again and our resource map, that NAT gateway should now map to both our private subnets through our route table. So we should be good with internet connectivity from that EC2 instance. So let's go ahead and get over to our EC2 panel. We have one instance. We are going to create a new instance, and this is going to be called Laravel Demo Workers. And it's going to be of the same size and same type as our web, which is, we have Ubuntu. We're sticking on the free tier for this demo. Here, obviously, you would stick with whatever size that you need for your application. We're going to use the same key pair that we've been using. We need to edit the network settings so that we can deploy this to our VPC. And we're going to be deploying it to that private subnet number 1. I'm just going to stick with my naming convention. I'm going to grab this name. For the new security group, we're going to name it the same thing with the -SG at the end. Update this little message here with the same thing. So for security rules right now, I think we'll start off with this. At some point later on, we're going to have to add connectivity from this to our database instance and this to our cache tier. So we'll have to figure out what we have to open up later on. But for now, we'll just leave that the same. And then under advanced details, we scroll down to the bottom. We did this the last time. We're going to put in this script, which is going to git clone our DevOps library that we've been using to do our provisioning and our deployments. So I think we are good enough. So let's launch this instance. Okay, so here's our Laravel demo workers. It's still being spun up. It says it's running, but it's still initializing. We'll give that a few minutes and we should be able to connect into it. And just as a reminder, when we SSH into this worker tier, we're not going to be able to directly SSH into it because it doesn't have a public IP address. We're going to have to use our web tier as a jump box. So the process is we're going to SSH into our web tier, and then from our web tier, we'll use that to hop on and SSH into our worker tier. Okay, while this is provisioning, let's go ahead and SSH into our web tier. I have a Mac terminal open here on my desktop, and inside this directory, I have the private key that we're going to use to SSH into our instances. So we've done this in the past. And so that's the IP address of my web tier. And so now I'm connected to that EC2 instance. I have prepped this a little bit to be able to connect over to our jump box by already deploying the private key to this instance. And so if we look at what's inside of our .ssh directory. You can see that private key that's already there. And I got that there by using SCP from the desktop. So not from within this instance, but from the desktop, I SCP'd and using the key to copy the key over to this EC2 instance, and I put it in the .ssh directory. So that's how I ran that before. All right, so now it says that our Laravel demo workers EC2 instance is up and running, and we're going to use the private IP address here. We're going to copy this. And now I have my connection. I'm on my web tier, so let's SSH using that private key into our new box. And so the first time through, it asks you if you want to continue, and do you recognize this box? Yes, we do. And so now we've connected into our new EC2 instance. So we've covered the provisioning steps before. So what we're going to do is we're going to use our provisioning scripts that we've copied in. We're going to look at our config file. The config.yaml file. So I've updated the deployment script, so now it uses this YAML file for configuration. And we're just going to configure what we need. So we need swap space. We do not need Nginx. We are going to need PHP and Composer and version 8.3. We're going to need Node and NPM to compile our assets. This does not need Redis because we're using Elasticache. This does not need SQLite. This does not need a MySQL database or a MariaDB. This is not going to have an SSL certificate, so we don't need that. And everything else is already set at no. So we're going to exit out of here. And now we're going to run our provisioning script. And that should take that configuration file and only install what we need to install. And this could take some time, so we're just going to let this run and we'll come back after it's provisioned. Okay, so we're back. That provisioning script has completed, and we'll just kind of review what happened here on our box. All right, so here's where we started the provisioning script. It updated the package list, and then we upgraded the packages based upon that update. And then we installed some basic packages. Then we started to do some installation based upon our configuration file. So we created swap space. We did not install Nginx. We installed PHP. We installed Composer because we're going to be needing Composer. Node and NPM we installed. We did not install Redis, MySQL, MariaDB, the certbot, Apache, Memcache, Beanstalk, so none of this stuff that got installed. We did one last upgrade check and we cleaned things up. And this is kind of the report at the end. Some of this stuff is not reporting out because obviously we didn't install some of it, but we're looking good there. Next thing is we're going to use some of our DevOps tools to actually deploy our application to this node. So before we do that, I want to take a look at what's in this common directory. And here under aliases, I want to show you what that looks like. We're not going to actually edit it, but I want to see what's in there. So that file creates 4 aliases that we can use. So we can use app list, app new, app create, app delete to actually deploy the application. We covered this in previous videos, but I want to make sure that we're installing those aliases. And we're going to resource this as it indicates there. Okay, so now those aliases should be available to us. So for example, if we do app list, there shouldn't be any existing applications. So we're going to run app new, and it's going to take us through a form, and we're going to answer some questions, and then it'll help us deploy our application. I'm just filling this out. We're not really deploying Nginx, so it's just asking for a port number, but this will not work. I'm going to copy and paste the URL in for the Git repo, and this public SSH key, and I'm going to paste something in for that too. So it's created this new demo_1.sh config file for us, and that just includes all of this information here. So the next step is we're going to run this, and it'll start to do the provisioning. And it's a 2-pass provisioning. The first pass is it creates a deployment user called demo_1. And then for this user, it creates the GitHub deployment keys and it cats one out so you can copy and paste this to your GitHub repos so that we can git clone from here. Or it does add www-data to our new demo_1 group. So this isn't really necessary because we're not really going to have Nginx running here, but this script actually is for the monolithic application, so it's not really fine-tuned for what we're doing here, but it's fine. It creates a .env file, and we will have to copy the .env file from our application node, and we're going to have to move it over to this node. And we'll take care of that in a little bit because we want the same kind of app keys and all that information in there. But we're going to go ahead and run this next step. So rerun it again for pass 2. Okay, let's review what it did on pass 2 here. So here's where pass 2 started, and it went through some of the same steps, but it didn't recreate the deployment user because it was already there. It created some authorization keys. So now we should be able to SSH into this box using our deployment user. Then it created some aliases for this deployment user. It updated MySQL. And in this case, it didn't find a MySQL command. So there's nothing really here for it to update. And that's fine because we're going to connect this up to our RDS instance here in a little bit. Created the initial deployment. So it git cloned down the code and then it did the build. So you can see composer install here. And down here, you're going to see npm install. So here's npm install, and then it built the front end in assets. This step isn't really necessary. We're not really going to serve up any web pages here, but it's just, again, doing everything. Migrations failed because the .env file isn't connected up and there's no MySQL engine here. And then it tried to activate this, but again, there's no Nginx running. So I think at this point, what we need to do now is copy over our .env file. And to do that, I'm going to need an SSH into our web tiers. This is the worker tier here, and I'm going to open up another tab. And this is going to be the SSH into our web tier. So right now I'm just on my desktop of my Mac, but we will connect up to the web tier. There's a couple of steps I have to do. The .env file that I want to secure copy over to my workers tier is actually inside the deployment users directory. That deployment users directory, I'm going to use that, but I need an SSH key. So first thing we're going to do is we're going to copy the SSH key from our Ubuntu user, which is right here. We're going to copy that so that the deployment user can use that also. And I'm going to need sudo for this. So this is our source file, and where we want to put this is in our demo_1. That's our deployment user. We want to put this into that user's directory. And so now if I list this out, we can see that that's here. And I had previously done this, so the owner of this, normally when you do this the very first time, this is owned by your Ubuntu user, so you're going to also have to run this command. And what this will do is this will change the ownership of that file from Ubuntu to demo_1. Okay, so the key is there. We are going to start a session up as the demo_1 user. Let me clear this all out. We're going to switch into our deployments directory. And just to orient everybody, what's in here, based upon our deployment script that we always use, this is a symlink that Nginx is using to serve up the whatever release that we're on. So we're under this release, and that's in the releases directory. But what's in the symlinks directory is our .env file. So I want to be able to secure copy that .env file from our web tier, and I need to put that over into our worker tier. So that's what we're going to do next. Okay, I'm going to copy and paste a command on that I think should work. So secure copy, we're going to use the private key that's now in our .ssh directory. We're going to copy over this symlinks /.env file. And we're going to go, this is the remote machine now. So the Ubuntu user, that's the IP address. And we're just going to place this in the home directory of that remote user. Yes, we will. And that copy has been completed. So now we're going to switch back over to our worker tier. And in our worker tier now, if I list what's in our root directory, I should see a .env file. So the first thing I want to do is I want to move that .env file from this user's directory over to our deployment user. So we're just going to put it for right now into this deployments directory. And I should say that right now, this is a lot of manual steps. I mean, we're kind of going through this so that we can see what all the steps need to be. And that's kind of the first pass through. And the second pass is what we really want to end up doing is automating all of this. We write scripts to make this happen kind of automatically for us. But let's get through the deployment manually here first. So now we're going to create a session for our deployment user. And we're going to switch directories into our deployments directory. And here we should see our new .env file. We don't want it there. We actually want it inside the symlinks directory. And so in symlinks there is an existing version. It's old and we don't need that. So we're just going to go ahead and remove the old one. And then we'll move in this new one. So if we list what's in symlinks now, we should have our .env file. I do see that that file is owned by Ubuntu. From security reasons, this user doesn't have sudo privileges. So we're going to have to bounce out of here. Okay, so what we want to do is we want to sudo change ownership. And the new owner is that. The new group is this. That file is here. So if we get back into our deployment user, and we look at our symlinks directory, now our .env file is owned by demo1, demo1. Okay, so we've got the correct .env file. And if we take a look inside, we can see the reason why that was all important. So we want to be using the same app key on this worker tier as we do on the web tier. Down here, we want to also use the same database connection, which right now we're doing read and writes both to our RDS connection, that's where we have it. And we want to be using the same queue. We're using Redis for our queue. So you can see our Elastic hash configuration is right there. So that's the reason it's important to have those. Next thing I want to do is let's go ahead and test out our database connection. The easiest way to do that is we'll switch over to our current deployment. And if you see what's in here, this is just a typical Laravel application directory structure. And to test out our database connection, what we're going to do is we're going to run php artisan migrate. This shouldn't find any new tables because it's already been migrated, but it will just kind of look into the database and see if it works. And you can see right now that this is going to get held up. And the reason that is we haven't configured a security group to allow this EC2 instance to connect to our RDS. So let's do that next. So back in our AWS console, we're going to go to our RDS area, look at our DB instances. This is our instance that we're running, so we're going to click on that one. And if we scroll down here a little bit, what we're going to see is these connected compute resources. Right now, this is our web tier. That's the EC2 instance for our web tier, and that's the only one that's connected, and that's why that functions. What we want to do is we want to add our new worker tier. So let's go ahead and set up a new EC2 connection. And this is pretty easy. We're just going to select the instance, which is our demo workers. Click continue. And here it's just kind of summarizing what it's going to do. But it's going to create the security groups that allow the connection on both sides of this thing. So we're going to just allow it to do that setup. And it says that the connection has been successfully completed. So if we select this and we scroll back down, Now we see two EC2 instances here. If I go back and run that PHP artisan command, that connection should be allowed. So let's try that out. So here we are. The last time we tried this, we had to cancel out because it couldn't connect. Let's go and try it again. And now you see there's nothing to migrate. So we've just kind of proven that our ability to connect to the database is working. All right, next thing I want to test is that this can connect to our Redis queue. And we can test that by looking at our Laravel Horizon dashboard. And this is being served up from our web tier. So this is an endpoint that's on our web tier. It's serving this Horizon application up. I haven't changed anything on our web tier yet. The web tier is still scheduling jobs and it's putting new jobs on there so you can see those. But what I want to do is I want to manually deploy a job from our worker tier and make sure it shows up here on the queue. So if I look at the completed jobs here in this queue, these are all Inspire jobs. These are the ones that are being scheduled by the scheduler. So what we're going to do is we're going to run a test job here. So now we're back in our terminal and this is on our worker tier. What I want to do is look at all the artisan commands. And if I scroll up to the top, there are two artisan commands here for our application. This is a test command, and this is going to queue up just a sample job onto our Horizon queue. So we're going to run this command from our worker tier to make sure that this is functioning. And it returns successfully. And we go back to Laravel Horizon. Here's our test job. So this test job was queued from our worker tier. So we know our worker tier has access to the Redis queue, which is an Elastic Cache instance. And because the first time we deployed this, there was a .env file that had the wrong connections, I want to just restart a few services. So I'm going to restart Supervisor. And I also want to restart our cron jobs. And if we inspect both those services now, let's go ahead and look at the status for them. So you can see that both Laravel Horizon and this Pulse are actually running. Now in this particular box, we do not need this Pulse to run. In fact, we don't want it to run here. So I'm going to go ahead and kill this, this job on Supervisor. Okay, so we're going to switch into our Supervisor directory. And there will be a conf.d directory. And if we look and see what's in conf.d, you're going to see this is the Horizon and this is for Pulse. So we're going to go ahead and remove this Pulse configuration. And so after I remove the file, I have to have Supervisor reread its config directory and it sees it's disappeared. And then what we'll do is have it update. And now if I look at the status of that service, we can see that it stopped the Pulse. Horizon is still running. All right, so that should be where we want that. All right, let's look at the other service that we restarted, which is the cron service. And here we can see that once a minute, we are running our PHP artisan schedule command. That's what we want there. So if we come back to Horizon here on our dashboard, let's look at our completed jobs. We can still see that they're coming in about every minute, which is what we're expecting. However, right now, PHP Artisan schedule is being run on both the web tier and the worker tier. It looks like maybe Laravel's handling the concurrency behind the scenes, but I want to shut down that process on our web tier now that it's running on our worker tier. So we come back to our terminal windows. Again, the left side, this is our worker tier. So we're going to switch over to our web tier and we're going to exit out of this demo_1 user. And now if we look at the status of our Supervisor service, we're going to see that Laravel Horizon is running down here. And I don't want that to be running here. I want it to be only running on our worker tier. So we're going to go over to the conf.d directory. And in this directory, we're going to do the opposite. So we're going to remove that config file. We're going to have Supervisor reread its config directory, and then we're going to have it update. So it's now stopped the Horizon So next, let's take care of the cron tab, and that is set up in each deployment user. So if we look at Crontab -E, we will see this cron tab for that deployment user. So every minute it's running, it's changing directory into our current deployment, and then it's running PHP artisan schedule. So we want to stop this. And if I look for help here, there is an option to delete the current user's cron tab, which is -R. So that's what I want to do. And so we'll exit out of this deployment user, and we're going to go ahead and just inspect the service one more time. And we can see that it was running once a minute, but at this point it should not be running anymore. Just for good measure, let's just restart that service. Okay, so we pulled up the Laravel Horizon dashboard again. At this point, we've completely disconnected our web tier from anything with the queue. So it doesn't have the PHP artisan schedule command. It's not running PHP artisan Horizon. And so this now is totally being driven by our new worker tier. Let's look at our completed jobs. And what we want to see is a new completed job being added to this queue. They're added once a minute. So let's just give it a moment. And so now you can see that there's new entries here. So we load the new entries. That's the job that just came. That was scheduled from our worker tier. So let's circle back to where we are now. So we've manually deployed the workers and the scheduler to an EC2 instance of their own. Took some time, a lot of manual process. Probably want to update that into our infrastructure as code and our deployment scripts. So we've got this web tier now all on its own, and that's going to help us out when we start talking about videos for scaling the web. This is our deployment infrastructure, what it looks like. We had to set up a NAT to allow our EC2 instance outside access to the internet so we can apt install and do everything we need to do here. We provisioned this. We deployed our application here. We set up PHP artisan schedule and PHP artisan Horizon. So that's all running here. Our Laravel Horizon endpoint is still being served up by our web tier. That's functioning. But all the scheduled jobs and everything that's being processed is now handled by the worker tier. All right, so just a few things to consider before we wrap things up here. Laravel Horizon has a configuration file. Look in the documentation. I'm not going to go into it right now, but that's going to allow you to configure the number of workers that Horizon can automatically scale to. So you can set a max, you can set a min. As jobs enter on the queue, if the queue looks like it's getting backed up, Horizon will automatically spin up new workers for you. So it's a very nice feature here for Horizon. Just go look in the documentation. It's pretty easy to use. Second thing is, so if you find out that your workers just aren't able to handle the workload, they're not really keeping up, and your queue never reaches that zero state where everything is completed, then you probably will need to scale your instance vertically. So more RAM or more CPU, depending upon where your constraint is. So definitely consider that. And then the third consideration, like I mentioned before, is we did this very manually. There's a lot of steps. So the current GitHub workflow is to push that update automatically to our web tier. Our worker tier isn't getting an update automatically. So at some point, I'm either going to have to manually go in and kind of update the worker tier, or the right thing to do is to automate our deployment scripts so that it automatically is pushing over that deployment to our worker tier. All right, and before we head out, let's just talk about what's coming up in the future videos. Now that we've got our web tier separated off, we started off with this big monolithic application, right? Everything was deployed to one EC2 instance. And now here we are. We have 4 tiers. Our database is running on its own. We have an RDS instance. Our cache is running. We have an elastic cache. So all of our data is in managed instance. And this is all kind of serverless for us. We don't really have to have any servers of our own. Our workers have been partitioned off on their own EC2 instance, so those are working on their own too. And now our web tier is by itself. Our next couple of videos, we're going to start looking at how do we configure our web tier for optimal performance. Configuration for Nginx and PHP FPM are critical for that. We're going to look at vertical scaling for the web tier, and then we're also going to look at horizontal scaling for the web tier and deploy multiple EC2 instances behind an application load balancer. So those are all upcoming videos. If you're interested in that content, hit the like button and subscribe.